Hello everyone, welcome to your exam math revision. We'll go through all the topics step by step in a clear and fun way. I'll give you examples, show you how to practice and prepare for your exam. When we count, we are trying to find out how many things there are. It helps us understand the quantity. When we compare numbers, we are trying to see which number is greater, which is smaller, or if they are even equal. To do this, we always look at the digits from left to right, starting from the biggest place value. A number with more digits is always greater. For example, a 6-digit number will always be bigger than a 5-digit number. If the numbers have the same number of digits, we compare the digits by the digits from left to right until we find the first place where the digits are different. The number with the biggest digit is the greatest number. When we order numbers, we either place them from smallest to biggest, which we call ascending order, or from biggest to smallest, which we call descending order. So remember, ascending means the numbers go up from smallest to biggest, and descending means the numbers go down from biggest to smallest. We all use symbols to compare the numbers, as you can see here on my screen. Let's talk about number sentences. A number sentence is just a math sentence, a way of writing something in math using numbers, symbols, and an answer. Just like English, where sentences make complete through, in math, a number sentence show a complete idea using numbers. There are different types of number sentences. Some number sentences show calculations, like this one: 32 plus 44 equals 77. This one is correct because it if we add 32 and 45, we really do get 77. Other number sentences use comparison symbols like less than or greater than symbols to show how two numbers compare. So this is basically this big we usually talk about that fish that would take the um more fish, the it looks like a half arrow, so we use that symbol as you can see on my screen. So 92 um and 192. This is also correct because 92 is less than 129. But now let's look at this one. 104 isn't uh, equal to 140. This isn't correct as it is shown on screen because 104 is not equal to 140. We use the equal sign only when both sides of the number sentence are exactly correct. Here, 104 is a smaller number than 140, so this number sentence is wrong. This is not equal. That's why we must always double check our number sentences. Whether we are adding, subtracting, or comparing, we must make sure they are true. Think of it like checking your answers in a test. Don't just guess, always show your steps to make sure your number sentences make sense. Let's look at how to add and subtract using the column method. The first and most important step is to line up the digits carefully in columns. If you don't add them up in columns, I can't mark it correct because then it's wrong, because then it's not the column method. This means putting the units under units, tens under tens, hundreds under hundreds, and so on. When we are adding, we always start from the right hand side, which is the unit column. If the total is in one column, is more than 9, we can't write two digits in one place. So we write down the second digit and carry the first digit over to the next column on the left. Like we've done here with the 7 plus 6 is 13. We keep the 3 here and we take the 1, the 10, to the next column. When we are subtracting, we always start from the units column as well. If the digit on top is smaller than the digit below it, we can't subtract. So we borrow from the next column. To the left, we take 1 from the column and add 10 to the current digit to help us subtract. As you can see here from this example on screen. It's very important that we show all our steps clearly. Don't skip a step or only write the answer. Even if it takes a few lines, it shows your thinking and helps me understand your work so that I can give you the right amount of marks. So remember, line up your digits in columns. Show me, write with pencil your columns so that I can see it's in columns. Start from the right hand side. Carry when adding more than 9. Borrow when subtracting with a smaller top digit. And always show you all your work very neatly. Fractions and how to simplify them can sometimes make you confused. Listen how I explain the difference between the LCM and simplifying fractions because these two are often get confused, but they are not the same. So let's first see what is a LCM. LCM stands for least common multiple. It is the smallest number that two or more numbers can divide into exactly. We find it by looking at the times table of each number and choosing the first number they have in common. We mainly use the LCM when we are adding or subtracting fractions that have different denominators, so different ones at the bottom because we need to find a common denominator. Examples of simplifying fractions. Let's look at these two examples that we have on screen. Example 1, 12 over 20 is divide top and bottom by 4. So we get 3 over 5. We simplified the fraction by dividing both parts with 4. Example 2, 9 over 27. You divide by 9. That gives us 1 over 3 because 9 divided by 9 gives us 1 and 27 divided by 9 gives us 3. And that's how we get our final answer 1 over 3. Again, we simplified by adding both parts by 9. These are called simplifying fractions, not the LCM. We are just making the fractions smaller and neater. The real LCM example, let me now give you a real example of how we use the LCM. Example 1. What is the LCM of 4 and 6? The multiples of 4 is 4, 8, 12, 16. Just stop there for now. Let's look at the multiples of 6. 6, 12, 18, 24. The first number they both share is 12. So the LCM is 12. Let's use that in our sum. So 1 over 4 plus 1 over 6. Remember, if the denominators are different, we can't add them together. So we change both to have the same denominator, which is 12, as we saw by writing out our multiples. 1 over 4 becomes 3 over 12 because if you times on the top, you have to times on the bottom with the same number every time. Remember that. So 1 times 3 is 1 times 3 is 3 and 4 times 3 is 12. Let's do it with the 1 over 6 as well. 1 times 2 is 2 and 6 times 2 is 12. So now we can add 3 over 12 plus 2 over 12 equals 5 over 12. That is how the LCM helps us work with fractions with different denominators. Why are timetables so important? To work out the LCM quickly, you need to know your timetables. If you know them well, you can easily spot the first numbers that appear in both lists. Timetables also help when simplifying fractions because you need to know how to know which numbers can divide both the top and the bottom. So times tables are super important in both simplifying and finding the LCM. So let's quickly summarize this page. The LCM is the smallest number that two numbers share in timetables. We use it to add and subtract fractions with different denominators. Let's look at simplifying fractions. This means making a fraction smaller by dividing the top and the bottom by the same number. Like for instance your examples 12 over 20 that makes 3 over 5 and 9 over 27 that makes 1 over 3. They are all examples of simplifying, not the LCM. Knowing your timetables makes everything easier, so please go and study them very um good so that you can remember them. How to read it, how to understand the different units, and how to convert between them. Time is one of the most important things to understand, not just for school exams, but for your real life. You use time every single day, whether you wake up, get ready for school, or planning how long your tasks will take. So it's very important to know how time works and how to work correctly. Let's start remembering the basic units of time. 1 minute has 60 seconds. 1 hour has 60 minutes. 1 day has 24 hours. And 1 week has 7 days. These numbers 60, 60, 24, and 7 are the key converting times. If you remember them, you will be able to change time from one unit into another easily. So if you want to, do you see this diagram with the blue arrows down below the screen? Please use this diagram to understand and convert time units. So let's do examples together. Example 1. How many minutes are in 2 hours and 15 minutes? We can break it up into parts. 2 hours equals 2 times 60, that equals 120 minutes. Add the extra 15 minutes, so it's 120 plus 15 equals 155 minutes. So 2 hours and 15 minutes equals 155 minutes. Guys, that minutes as well at the end of your answer. You have to add it in. Otherwise your answer is not correct. You can't just write 135 155. You can't just write it because I can assume it's seconds, I can assume it's hours, or I can assume it's years, minutes, centuries, decades. So you must always put the unit at the end of your answer. Otherwise, your answer is not correct and I will not be marking it correctly. Let's look at example 2. What is 150 minutes in hours and minutes? So first divide 150 by 60 as we can see on this diagram down below. So 150 divided by 60 equals 2, remainder 30. That means there are 2 full hours and 30 minutes left over. So 150 minutes equals 2 hours and 30 minutes. And remember, you have to add in your units. Here's a tip. If you get stuck, use a timeline or draw a picture to help you. For example, draw 2 full hours and then add 15 minutes more. This helps you to see the parts of time clearly. Also, always show your working so that your teacher can see how you fought through the problem. The best advice that I can give you is use this diagram down below. You all know how to use it, and then you will be fine for the exam. So let's talk about the 2D shapes. These are shapes that are flat. That means that they only have two dimensions, 2D, two dimensions, length and width. They don't have any depth or thickness. Now let's look at a few examples. A square is a very neat and regular shape. It has four sides that are all the same length and four corners with that we call angles. Each of them have an angle is a right angle, which means they are exactly 90 degrees. A rectangle is very similar to a square. It also has four right angles, but the opposite sides are equal in length, not all four sides. It looks like a stretched square, basically. Triangles are interesting because they come in many different types. So we get different types of triangles. All triangles though have three sides and three angles, but the lengths of the sides and the sizes of the angles can be different. Some triangles have all equal sides, while others have one long side or one big angle. That's why we need to pay close attention to the length of the sides and the sizes of the angles to name them correctly. Circle is a very unique shape. It doesn't have any straight sides or corners. Instead, it has one curved edge, that means it bends, that goes all the way around. We say it is a curved boundary. It is very important that you learn and recognize all the names and all the shapes quickly. On this slide, you'll see a picture of different 2D shapes along with their names and some of their properties. But remember, you need to know all your 2D shapes that we've talked about in class and that are in your textbooks. So not just the ones that's shown on the slide. So pay attention to each shape, name, and how many sides it has, and what kind of angles it includes. Data is information we collect from the world around us. You can find data in many places on cereal boxes, sports scores, weather reports, and even in the classroom. When we collect data, we often write it down in tally tables. A tally table helps us count quickly and neatly using tally marks. After we collected the data, we can organize it into pictographs or bar graphs to help us see and understand the information better. When you read a graph or a chart, always follow these steps. Start by reading the title so you know what the graph is about. Look at the labels on the sides and at the bottom. These tell you what the numbers and pictures mean. If you are reading a pictograph, make sure you check the key. The key tells you what each picture stands for. For example, one apple might stand for 5 votes. Read the scale carefully, especially on a bar graph. The numbers must be read correctly so you can understand the values. Now let's try an example. Imagine a pictograph where each apple represents 5 votes and you see 3 apples. Next, bananas. That means 3 apples times 5 votes equals 15 votes for bananas. Use your brain and don't rush. Always double check the graph before answering. And remember, when you answer a question like which item had the most votes, look at the graph, use the title labels and key, and explain your answer using what you see in the data. Don't just give your answer. Here are a few examples of different types of graphs. A pie chart, a circular graph divided into slices to show different types of aspects. Each slice represents a part of a whole, useful for showing percentages or comparing parts to a whole. Number two is a bar graph. Uses bars of equal widths to represent the data. You have to know the columns have to be the same size as well as the spaces between them. The height of each bar shows the value of the data. Always check the scale on the axis and always be able to label your axis clearly. Bars should all be the same width and evenly spaced as I said previously. A pictograph, this is the one with the smiley faces, uses pictures or symbols to represent data. Each picture is a symbol that must be represented the same number of quantities. A key is always provided to show what each picture represents. Make sure the picture are neat and clear. A tally chart, as you can see there on top, used to collect and count data quickly. Tallies are grouped into five. So, for instance, that stripes, it has to have five stripes there or four stripes, and when it goes horizontal, then you know it's a five, as you can see on top. A total is usually shown at the end of each row. Very important reminders. Please remember, if you are asked to draw a graph in a test or activity, you must always include a main title for your graph, labels or titles for your axis, so your next to each other, as you can see here with the bar graph, the number of books or years in orange. That's very important. A scale that is accurate and constant. For example, going up, you count in twos or fives or tens. You can't say 1, 3, 9, and so forth. It has to be in a certain, if you want to say multiples of timetables. A key or a legend, if needed, especially for a pie chart and a pictograph. And use a ruler when drawing straight lines and bars to keep it neat and clear. Make sure the bars in the bar graph are all the same width and evenly spaced. You can see from a graph examples on the slides that they follow these rules. All bars are the same size, the spaces between bars is even, titles and labels are clear and easy to read, everything is according to scale. This helps make a graph accurate, easy to understand, and professional. Okay, number patterns. These are sequences of numbers that follow a specific rule. Think of them like little puzzles or codes in math that you need to figure out. Once you find them, rule the rest becomes easy. Start by looking at how the numbers are changing from one to the next. Are the numbers getting bigger or smaller? Are you adding, subtracting, multiplying, or dividing by the same numbers each time? And that repeating action is called a rule of the pattern. For example, let's look at pattern 1. 2, 4, 6, 8, 10. Here the numbers are increasing. Each number is 2 more than the one before. So the rule is plus 2. Pattern 2, 100, 90, 80, 70. Here the numbers are decreasing. Each number is 10 less than the one before it. So the rule is minus 10. Now let's practice using a pattern. Fill in the missing numbers. 5 space 15 space. To solve this, we need to find the rule. Let's look closely. From 5 to 15 is a jump of plus 10, but there is a number in the middle, so we divide that jump in a half. So the pattern must be going up by plus 5. Each time 5, 10, 15, 20. So the rule is plus 5. Patterns helps you later in algebra. So the more you practice now, the easier math will be for you in the future. Always remember, find a rule, complete a pattern. It's as easy as that. All right, class, today um, on this slide, we're going to look at multiplication using the column method. So our first example is 29 times 65. We use the column method to make multiplication using long, bigger numbers that's more difficult to multiply easier. So we're going to use this example. So now I know that looks a bit scary at first, but don't worry. We are going to break it into smaller, easier steps to make this easier. Step 1, break down the number. We split both numbers into tens and units. So 29 becomes 20 plus 9, and 65 becomes 60 plus 5. Why do we do this? Because it's much easier to multiply simply numbers like 20 and 5 than trying to do 29 times 65 all in one go. I mean, some people can't do that. I know I can't do that. To know each timetable, it is going to be impossible. So now we draw a little grid or table to help us organize this. So basically, you use lots of columns. Step 2, multiply each part. We take each part of the first number and multiply it by each part of the second number. So first let's do 29 times 5. You can think of this as 20 times 5 that equals 100 and 9 times 5 that equals 45. Then we add 100 plus 45 that equals to 145. Now we move on to the 29 times 60. This is a trickier part, but don't panic. This time we do 20 times 60. This gives us 1200, and 9 times 60 that gives us 540, and we add them together. So 1200 plus 540 equals 1740. We'll write that one down in pink, as you can see on the screen. Now, here's something important to remember. When you multiply by 60, you are multiplying by a number with a 0 at the end. So, your answer must also end with a 0. That's why we always remember to add a 0 when we are using the long multiplication method with tens. It helps us keep our place value correct. Step 3, add everything together. So we take our two answers, 145, so from the 29 times 5, and the 1740 from the 29 times 60, and now we add them together. 145 plus 1740 gives us 1885. So the final answer is 29 times 65 equals 1885. Tips while doing this: always line your numbers properly when you add. Use your ruler to draw your grid or underline your steps neatly, so basically your columns. Check your multiplication facts, like little mistakes can sneak in. And most important, always show your working. Even if you make a mistake, showing your steps can help you still get marks. This method is a great way to organize your thinking and not get overwhelmed by big numbers. So, next time you see a tricky sum like this, just remember, break it down, multiply, and add up your answers. Okay, guys, 3D shapes, and you have to know it's everywhere. Think about a dice, that's a cube, or a cold drink can, that's a cylinder. Learn to count the faces, the flat surfaces, the edges that are the where the faces meet, and the vertices, the corners. Touching and seeing real objects can help. If it rolls, it probably has a curved surface. Here are the few properties of 3D shapes you need to know. All the shapes that we have learned this year, not just the ones on the screen. I just wanted to show you basically what's on the screen, but you have to know everything that's in your textbooks and what we have covered. Symmetry. Symmetry is when one half of something looks exactly like the other half. You can fold it and the halves will match. Patterns are like dances. They follow step by step. A shape or color might repeat every two or three spaces, but it's still a pattern. Once you find the patterns, you can predict what's next, as you can see here on screen. Okay, now we are going to take a good look at long division. I also have a separate video on long division, so I'm going to just explain this one um quickly but still in detail. But if you want to go watch that other video I made on long division again, if you want to go in full depth, because I know some of you really struggle with long division, and that the only reason usually is because you don't know your timetables. You need to know it for this. So we're going to take a look at long division. Sometimes division can feel difficult, especially when the numbers get bigger. But don't worry, if you follow these 5 easy steps, you can do any long division sum. Let me first tell you what the steps are so that you can remember the order. It's divide, multiply, subtract, bring down, remember. Other people can say it's daddy, mommy, sister, brother. Okay. And then you have to repeat. If there's anything left, it's called a remainder. Let's learn what each of these steps mean by doing an example together. Example 1. For this slide, it is 74 divided by 3. We want to divide 74, the bigger number, by 3. So ask yourself, how many times does 3 go into 7? Well, 3 goes into 7 2 times. 3, 6. And then the next one's going to be 9, so it can't be, so it's only 2. So we write 2 above the 7, as you can see here. Now we multiply. 2 times 3 equals 6. Next, subtract. 7 minus 6 equals 1. Now we bring down the next number, which is 4. From 74, now we have 14. How many times does 3 go into 14? 3, 6, 9, 12. So 3 goes into 14 4 times because 3 times 4 equals 12. So now we subtract. 14 minus 12 is 2. Now we check. Is there anything left to bring down? No. So 2 becomes our remainder. Final answer 74 divided by 3 is 24 remainder 2. You can also write this as 24 or 2. Or if you're using decimals, you can continue and write it as 24 comma with comma 6 with rounding. Let's review the 5 steps again. Divide. How many times does the divisor fit into the number? Number 2, multiply. Multiplying your answer by the divisor. Subtract. Subtract to see what's left. Bring down. Bring the next digit down. Remainder. If there's no more digits left, bring down. Whatever is left is your remainder. And then that's how it works. Now let's talk about some important properties of division. These will help you understand what to expect when dividing. Dividing by 1. When you divide any number by 1, the answer stays the same. For example, 10 divided by 1 equals 10. 5 divided by 1 equals 5. It's like saying how many groups of 1 are this number. The number answers is the number itself. Dividing a number by itself. When you divide a number by itself, the answer is always 1. So if I say 5 divided by 5, it's 1. 10 divided by 10, it's 1. 8 divided by 8 is 1. Dividing by 0. This is not allowed and it's impossible. Any number divided by 0 has no meaning. We call it undefinable, undefined. For example, 35 divided by 0 doesn't, it's not equal, it is impossible. Even if you go put it in your calculator, it will say error. So always remember, you can never divide by 0. 0 divided by any number, now this one is okay. If you divide 0 by any number, the number is always 0. For example, 0 divided by 25 equals 0. 0 divided by 10 equals 0. Think of it a way. If you have nothing and you divide it among people, each person still gets nothing. As easy as that. Okay, let's talk about something super important, how to convert fractions into decimals. Sometimes we see numbers written as fractions, like 1 over 2 or 3 over 4. And other times we see them written as decimals, like 0.0,5 or 0.75. But did you know that they are just two different ways to show the same value? Let's learn how to change these fractions into decimals step by step. Step 1. Understand the fraction. A fraction has two parts. The top number is called the numerator. It tells us how many parts we have. The bottom number is called the denominator. It tells us how many equal parts the whole is divided into. For example, 3 over 4, 3 quarters. So 3 is the numerator, 3 over 4, and 4 is the denominator. So we have two methods. So let's look at method 1 first. Division. One of the easiest ways to convert a fraction to decimal is to divide the numerator by the denominator. So when you see a fraction like 3 over 4, you're basically being asked, what is 3 divided by 4? Now let's do the division. 3 divided by 4 equals 0.75. So 3 over 4 equals 0.75 in decimal form. Let's try two more examples together. 1 over 2 equals, um, we're going to see now, 1 divided by 2 equals 0 over 5. 1 over 3 is 1 divided by 3. That gives us 0, 3333. This is a repeating decimal. The 3 goes on forever. We write it as 3 with that stripe on top, with a line over the 3 basically. Method 2 is you use a calculator. Sometimes the division can get tricky, especially with large numbers. Example 5 over 8. Type 5 over 8 into your calculator. You'll get 0.625. So 5 over 8 is equal to 0.625 as a decimal. Important tips: if your decimal ends or stops like 0.5 or 0.625, it's called a terminating decimal. If your decimal repeats like 0.33333 or 0.66666, it's called a recurring or repeating decimal. Some fractions like 1 over 3 or 2 over 3 can't be written as a clean decimal, and the digits repeat forever. Remember, a fraction is a division. So to change it to a decimal, just divide the top with the bottom. Let's look at this. Fractions and decimals both are part of a whole, just in different ways. A half is the same as 0.5. A quarter is the same as 0.25. If you're unsure, divide the top number by the bottom one using a calculator or long division. Knowing these conversions helps us with money, time, and measurements. Here I've added in the most common decimals and fractions with percentages, as well as just another picture of the pizza and how many slices are left. 3 over 4, because there's 4 slices, but there are only 3 left. The top one, the 3, is the numerator. How many equal parts do I have? And the bottom one, number 4, the denominator, is how many equal parts is the whole divided into. Capacity and volume. Capacity tells us how much liquid something can hold. Like a big bottle might say 2 liters, but a juice box might be 250 milliliters. To convert liters to milliliters, multiply by 1,000. To get from milliliters to liters, divide by 1,000. Always check your units before answering. Use this diagram down below to convert it from milliliters, kiloliters, liters, and so forth. Word problems. Word problems are just math in story form. Take it slowly, read twice if needed, and underline the numbers and action words like all together, share, left, and so forth. So use your keywords to know exactly what to do. Decide: is this addition, subtraction, multiplication, or division? Then show your steps and check your answer to make and see if this word problem makes sense. You've worked hard to prepare, and now it's time to show what you know. Remember to stay calm, read every question carefully, and most importantly, show all your working. Even if you're unsure, always attempt every question. You've got this. Thank you so much for working so hard. Good luck, and remember to come and ask me anything anytime. Also, remember the only way to get better at math is to practice, practice, practice. Thank you guys. Good luck.